proceed further. Now we proceed further. So we have studied types of polynomial based on terms monomial, binomial, trinomial. Now we will discuss standard form of polynomial. Here standard form. Standard form. Now here I write some polynomials. First example, x square plus x to the power 5 plus x cube plus 3. One example. Second example, y minus y cube minus 2 plus y to the power 4. Here I have written two examples. Now we want to study standard form. So for standard form, whatever polynomial given to you, you have to arrange the terms of polynomial according to their power, according to their descending order of their power. We have to arrange them according to descending order of their power. So first of all, check this power maximum 5 and this term first. So here standard form. Standard form. First of all, this term x to the power 5. Then next descending power x cube. Then x square and then 3. Okay. Now here in this example I write this minus so that we can understand clearly. Now second example. Whatever given to you now, we want to write in standard form. Arrange these terms according to descending order of their powers. Arrange these terms according to descending order of their powers. So here standard form. Standard form. First of all, power 4. So write this term with sign. If there is minus sign, write this sign. Minus y to the 4. Then power 3, write this with sign. Minus y cube. Then there is no sign. Write down plus y and then that is minus 2. In this way. That is standard form of the polynomial. You have to arrange terms according to the descending order of their powers. Okay. Now in this, if we look, there are some terms missing. Power 5, power 4 is missing. Power 3, power 2, power 9 is x missing. Here power 4, power 3, power 2 is missing. Okay. Now based on the standard form, there is index form. Now index form. Index form. Index form. We have to write all the missing terms also by taking coefficient 0. Now first of all, by taking coefficient 0. So here, if I use this first example for index form, this example. So here, I am considering this example for index form. Power 5, power 4 is missing. So here, x to the power 5 plus 0x4. Then x cube is there already. So x cube. Then x square. Now x is not there. So 0x plus 3. In this way, whatever missing term, you have to take missing term according to their powers by taking coefficient 0. Okay. Now this second one in index form. This one we want to write in index form. First of all, power 4 minus y to the power 4, then minus y cube. Now after 3 we want power 2. There is no power 2, so plus 0 y square. Power 2, then power 1. Yes, there is power 1 y and then minus 2. That is standard form. That is index form. We have to write missing term by taking coefficient 0 according to their powers. So that is standard form, that is index form. Now one more thing that we want to study. So here we want to study coefficient. coefficient. So here coefficient. Here 3x cubed minus 2x squared plus 5. Okay. Minus 5y squared plus y. Now here I have written two polynomials. Now if I ask you a question, coefficient of x square. Coefficient of x square. I want coefficient of x square. Check this. Coefficient of x square. So take x square, whatever integer. I am not saying natural number, I am not saying whole number. Integer behind it. Integer behind it. That is integer behind it. With sign. That integer is called as coefficient of that term. So coefficient of x square, that is x square. So this integer is its coefficient minus 2. Minus 2. Okay. This example, I want coefficient of y square. I will short form coefficient of y square. Check this y square. Whatever integer behind it, that is coefficient. Now I have one more example. Half x cubed plus 3. Here I have the third example, and now here I want coefficient of x cubed. Now check this, x cubed, that is x cubed. I want coefficient of x cubed. So whatever integer behind it, that is integer. So here 1 by. If there is minus sign, then there should be minus sign. Okay. Integer behind the given term is called as coefficient of that term. So I hope you understand now coefficient also. Now based on this, you have to solve or practice say question 2 of 1.1 practice say question 2 practice or homework. Practice or homework. 1.1 second question, practice or homework. Now we proceed further also. So we have studied types of polynomial on the basis of term. Now we want to study types of polynomial on the basis of degree. Types of polynomial on basis of degree. On basis of degree. Here I have some examples. First example, 3x square minus 7 y plus 7 1 by 3 x cubed minus 5. Here I have got some examples. Now for this example, what is degree? Degree is 2. What is degree here? Degree is 2. So when degree is 2, that is called as quadratic equation. Quadratic polynomial or equation. Quadratic equation. When the degree of polynomial is 2, that is called as quadratic polynomial or quadratic equation. quadratic polynomial or quadratic equation. Okay. Now check here. What is degree? Degree 1. Degree 1, that is called as linear polynomial. Linear polynomial or linear equation. Linear polynomial or equation. Okay. So here we use the word polynomial. As we are studying polynomial, so we use polynomial. We use the word equation afterwards. That is linear polynomial. Linear polynomial. Okay. And when check the degree of this one, third one. Degree is 3. Degree is 3. So that is called as cubic polynomial. Cubic polynomial. Okay. So when degree 2, that is called as quadratic polynomial. Now don't consider terms. Don't consider terms. Here I have written 2 terms already in everyone. Now here on the basis of degree. On the basis of degree. When degree 2, it is called as quadratic polynomial. When degree 1, it is called as linear polynomial. When degree 3, it is called as cubic polynomial. And if we consider terms, 2 terms, that is binomial. Again 2 terms binomial. 2 terms again binomial. So we can classify polynomials on the basis of terms as well as on the basis of degree. On the basis of terms as well as on the basis of degree also. Okay. Now I proceed further.